Study Section 6, Random Sampling and Sampling Distribution. Introduction. In scientific research, as well as in our everyday life, our knowledge, attitude, and actions are based to a large extent on samples. Often, in practice, we are interested in drawing valid conclusions about a large group of individuals or objects. Instead of examining the entire group, which may be difficult or impossible to do, we may examine only a small part of the entire group. In this study session, you will be introduced to random sampling and sampling distribution. Learning outcomes for study section 6. At the end of this study session, you should be able to discuss the meaning of sampling, discuss population and sample as well as their characteristics, distinguish between random and non-random sampling. Sampling distribution. A sample is a group of objects or readings taken from a population for counting or measurement. Sampling deals with the methods of selecting part of the population under study whereby inferences made about the part are true of the whole population. Simply put, the process of obtaining samples is called sampling. The sample must be random, meaning that all possible samples of a particular size must have equal probabilities of being chosen from the population. This will prevent bias in the sampling process. Some definition of terms. 1. Population. This is simply the set of all observations of the variables under consideration or study. 2. Sample. This is a subset of a population, that is, part of the population under consideration. 3. Parameter. This is defined as any statistical measure based on population value. 4. Statistic. This is a statistical measure based on sample value. 5. Standard deviation. This is a statistical measure used to calculate variation of the data from its mean using all population value. 6. Standard error. This is a statistical measure used to calculate variation of the data from its mean using sample value. 7. Sampling with replacement. This is the process of taking sample from population by replacing the unit selected before the next draw is made. 8. Sampling without replacement. This is the process of taking sample from the population by not replacing the unit before the next draw is made. 9. Sampling unit. This is the object of investigation. 10. Sampling frame. This is the list of all units. 11. Sample survey. This is defined as the investigation carried out by making use of sample. 12. Census. This is defined as the investigation carried out by making use of the population. Advantages of sample over population. 1. A study of sample is less expensive than studying an entire population. 2. Samples can be studied more quickly than population. 3. A study of an entire population is impossible in most situations, such as destructive sampling, e.g., production of bulbs and its testing and infinite population. 4. Sampling results are often more accurate than results based on population. 5. Detailed information is obtained compared to studying the entire population. Random sampling. Basically, there are two categories of sampling, namely random probability sampling and non-random non-probability sampling. Examples of the latter are quota sampling, haphazard sampling, purposive or judgmental sampling. Random sampling. Random probability sampling is a method of selection which assigns a known non-zero probability of selection to every sampling unit in the population. In other words, the sample is selected in such a way that every item in the population has an equal chance of being included. This definition implies that the selection of the sample is left to chance, that is, the sample selected is free from bias. Types of random sampling. There are 5 types of random sampling: simple random sampling, systematic, stratified, cluster, and multi-stage. 1. Simple random sampling, SRS. This is a sampling procedure in which each item sampling unit of the population has an equal chance of being included in the sample. It is mostly adaptable when the population is homogeneous, that is, has similar characteristics, and the sampling frame is available. There are 2 basic ways of drawing a simple random sample. The lottery method, that is, by drawing chips or piece of paper with identity of the sample unit from a bowl or box. The other way is the use of random number table, used when the population is too large for the use of lottery method. Some disadvantages of simple random sampling include non-availability of adequate sampling frame. The selected sample may be one-sided, thereby not representing the population very well. 2. Systematic sampling. It is based on an equal probability method. The sampling starts by selecting an element from the list at random, and then every kth element in the frame is selected, where k is the sampling interval. K is equal to n over n, where n is the sample size and n is the population size. Each element in the population has a known and equal probability of selection. This makes systematic sampling similar to SSRS. 3. Stratified sampling. In surveys, when subpopulations within an overall population vary, it is advantageous to sample each subpopulation stratum independently. Stratification is the process of grouping members of the population into homogeneous subgroups before sampling. The strata should be mutually exclusive, that is, every element in the population must be assigned to only one stratum. The strata should also be collectively exhaustive, that is, no population element can be excluded. After grouping, SRS or systematic sampling is then applied within each stratum. This often improves the representativeness of the sample by reducing sampling error. Cluster sampling. The population within a cluster is heterogeneous as possible, but homogeneous between cluster means each cluster is a representation of the total population. The clusters are mutually exclusive and collectively exhaustive. A random sampling technique is then used on any relevant clusters to choose which clusters to include in this study. The main difference between cluster sampling and stratified sampling is that in cluster sampling, the cluster is treated as the sampling unit. So analysis is done on a population of clusters, while in stratified sampling, the analysis is done on elements within strata. The main objective of cluster sampling is to reduce cost by increasing sampling efficiency. This contrasts with stratified sampling, where the main objective is to increase precision. 5. Multi-stage sampling. It is a complex form cluster sampling. Using all the sample elements in all the selected clusters may be expensive or unnecessary. Under these circumstances, multi-stage cluster sampling becomes useful. Instead of using all the elements contained in the selected clusters, the researcher randomly selects elements from each cluster. This technique is used frequently when a complete list of all members of the population does not exist and is inappropriate. Random non-probability sampling. Non-probability sampling is a sampling technique where the samples are gathered in a process that does not give all the individuals in the population equal chances of being selected. Types of non-probability sampling. 1. Convenience sampling is probably the most common of all sampling techniques. With convenience sampling, the samples are selected because they are accessible to the researcher. Subjects are chosen simply because they are easy to recruit. This technique is considered easiest, cheapest, and least time consuming. 2. Consecutive sampling is very similar to convenience sampling, except that it seeks to include all accessible subjects as part of the sample. This non-probability sampling technique can be considered as the best of all non-probability samples because it includes all subjects that are available, that makes the sample a better representation of the entire population. 3. Quota sampling is a non-probability sampling technique wherein the researcher ensures equal or proportionate representation of subjects depending on which trait is considered as basis of the quota. 4. For example, if basis of the quota is college year level and the researcher needs equal representation with a sample size of 100, he must select 25 first year students, another 25 second year students, 25 third year, and 25 fourth year students. The basis of the quota are usually age, gender, education, race, religion, and sub-economic status. 5. Judgmental sampling is more commonly known as purposive sampling. In this type of sampling, subjects are chosen to be part of the sample with a specific purpose in mind. With judgmental sampling, the researcher believes that some subjects are more fit for the research compared to other individuals. This is the reason why they are purposely chosen as subjects. 6. Snowball sampling. It's usually done when there is a very small population size in this type of sampling. The researcher asks the initial subject to identify another potential subject who also meets the criteria of the research. The downside of using a snowball sample is that it is hardly representative of the population. Sampling distribution. Let's consider how statistics differs from sample to sample. If repeated simple random samples of the same size are drawn from statistical population. For example, a given statistic, such as mean, will vary from sample to sample. The distribution of this means x1, x2, x3 to xn, for instance, can then be examined to estimate the amount of variation that can be expected from one sample to another. The probability distribution of such statistic is referred to as a sampling distribution. Sampling distribution of means. Let x1 bar, x2 bar to xn bar be a random sample of n independent observations from a population with mean and variance. Consider the probability distribution of the statistic called the sampling distribution of means. We have the following theorems. Theorem 1. The mean of the sampling distribution of means denoted by is given by where x bar is equal to mean of the samples, or simply sample mean. Mu x bar is equal to mean of all possible sample means, and this is exactly equal to the population mean mu. Proof. Study the proof. X bar is equal to mu. Theorem 2. If a population is infinite, or if sampling is with replacement, then the variance of the sampling distribution of means denoted by is given by where variance is the population variance. Note that is also called standard error, and it measures the precision of the sample. Proof is equal to variance over n. Theorem 3. If the population is of size n and sampling is without replacement, and the sample size n is less than or equal to n, then n approaches infinity, n minus n over n minus 1 in bracket approaches 1. Theorem 4. If the population from which the samples are taken is normally distributed with mean and variance, then the sample mean is not normally distributed with mean and variance. Theorem 5. Suppose that the population from which samples are taken has a probability distribution with mean and variance that is not necessarily normally distributed. Then the standardized variable associated with mean is given by implying. This theorem is a consequence of the central limit theorem CLT, with an assumption that the population is infinite, or that sampling is with replacement. Example 1. Suppose a hypothetical population consists of the 6 numbers 2, 3, 6, 6, 8, 11, and 18. Consider all possible samples of size 2 which can be drawn with replacement from this population. Find A, the mean of the population, B. The standard deviation of the population. C. The mean of the sampling distribution of means. D. The standard deviation of the sampling distribution of means. That is the standard error of means. 2. Solve questions 1 above without replacement. 1. Mu is equal to 48 over 6 is equal to 8. B. N is equal to number of observations. Standard deviation is equal to 5.38852. C. Possible samples drawn with replacement is equal to 6 squared is equal to 36. These are the corresponding sample means are. Therefore, the mean of the sampling distribution of means is N is equal to number of observations. That is, mu mean is equal to mu. D is equal to N is equal to number of observations. N is equal to size of samples drawn. That is equal to 14.5. 2. A same as 1A above. B same as 1B above. C. Possible samples to be drawn without replacement. These are note. 3 is considered the same as 2. The corresponding sample means are. Therefore, mean of sampling distribution of means is, which shows that D. Mean of the standard deviation is equal to N is equal to the number of observations is equal to 3.406, which shows that N is equal to population size, N is sample size. Mean of the variance is equal to 11.6. Summary of study section 6. In this study session, you have learned that 1. A sample is a group of objects or readings taken from a population for counting or measurement. 2. Sampling deals with the methods of selecting parts of the population under study, whereby inferences made about the part are true of the whole population. 3. There are 2 categories of sampling, namely random probability sampling and non-random non-probability sampling. 4. Random probability sampling is a method of selection which assigns a known non-zero probability of selection to every sampling unit in the population. This is the end of study section 6. Thanks for listening.